Started. So I'm Stephen Haben. I'm a senior AI consultant at the Energy Systems Catapult. Welcome and thanks for joining us again. These are value in energy data seminars where we try and present learnings and the brilliant work that's going on in the world of digitalisation in the energy sector. Today I'm very happy to introduce Jonathan Barcroft from the National Grid ESO. First talk we've had from someone from National Grid ESO, so we're excited about that. I'll do a little introduction about Jonathan and then he'll start his talk. So, yeah, Jonathan Barcroft leads the Common Framework workstream of the Virtual Energy System Program at National Grid Electricity System Operator. He joined in 2012 and his background is in operational power system engineering and improving energy data process. In 2015, Jonathan developed the export process for the first common information model-based day-ahead model exchange from National Grid to Core ESO. And since 2021, Jonathan's been part of the innovation team at the National Grid ESO, leading projects investigating the risks of climate change to the power system and the optimization of operational planning. Jonathan, if you would like to share your screen, please go ahead.
Thank you. So hopefully the slides are loading up.
Yep, I can see that. Thank you.
Perfect. Oh, use different on mine though. There we go. Hopefully you can still see the slides and not my speaker view.
No, just the slides. Brilliant. Thank you.
So thank you. Thank you for the opportunity to share an introduction and an update on our virtual energy system program. First, just as an introduction to our organisation for anybody who isn't familiar with the ESO, we're the Electricity System Operator, an independent company within the National Grid Group. We'll soon become the National Energy System Operator, a public body with expanded responsibilities including strategic planning across the whole energy system and providing independence and advice to government. Our current responsibilities for reliable, secure system operation to deliver electricity when customers need it will continue, while facilitating that competition and transformation to smart systems and markets. The Virtual Energy System is an ambitious whole energy innovation programme to enable the development of an ecosystem of connected digital twins, representing the whole energy system of Great Britain and to help solve wider system challenges. It'll allow models and data representing the assets and behaviour of the energy system to be shared and used to support optimisation, strategic planning and reporting. Working with industry and with government, we've identified that the first step towards this goal is creating a common data sharing infrastructure that allows for secure, resilient and assured sharing of data between organisations across energy. Delivering this data sharing infrastructure is both a social and technical challenge, requiring the development of capabilities and collaboration, as well as the technology solutions. To achieve this, we've proposed a common framework, 14 areas of focus representing both those social and technical factors that we believe are required to support this ecosystem. Starting with data, we need to increase visibility and sharing, making it both findable and accessible. To make it easier to understand and use, we need to align models and taxonomies using common data exchange standards. And this needs to be supported by appropriate security and data governance functions to ensure that it's shared safely and in accordance with the permissions and sensitivities assigned to it. In process, we need to engage with experts across the sector and beyond, as this is not a mission that can be achieved alone. We need to develop a governance framework that creates the decision-making processes to facilitate collaboration and participation. And it's clear that development on this scale needs to be viable and sustainable, built on clear funding and business models. All of this is set in the context of existing industry codes and standards to form around. To create this ecosystem through collaboration includes forming a shared culture. Defining roles and responsibilities will help with developing an understanding of the capabilities and skills required to develop the component parts and support them in the longer term. Underneath this are the technology factors. Forming these digital twins will necessitate connecting existing and forming new connections between the physical infrastructure and digital world. To be able to analyse and visualise these new sources of insight, we'll need enhanced modelling and analysis capabilities. And to create these scalable connections between organisations will be dependent on creating an interoperable tech stack, which can be adopted in a wide range of different environments and organisations. We've completed the initial exploration of the first 8 key factors, which we consider the first among equals. that have helped define the design principles and refine the development requirements to identify the solutions that we'll present in today's session. So recently, you might have seen that the Government Department for Energy Security and Net Zero published the conclusions and recommendations of their digital spine feasibility study, which built upon the proposals of the Energy Digitalisation Task Force. This project identified that a data sharing infrastructure for energy should be comprised of 3 component activities: to prepare, trust, and share. The prepare activity is performed by a commonly structured data preparation node, which was previously termed as a digital spine node, on an organization's own infrastructure. These nodes are deployed by each organization participating in the data sharing infrastructure using an open source systems architecture up to an API endpoint. The trust activity defines and implements and governs the legal and identity rules that ensure reliable data sharing. This includes the collaborative process of agreeing data sharing rules, the integration of processes for organizations to implement rules through their preparation nodes, and the share activity includes the connectivity layer and the technological implementation for that governance of access controls to the data. The Digital Spine Feasibility Study identified several ongoing initiatives across the energy sector and beyond, and identified that these activities were currently in development through the identified programs. The National Digital Twin Programme is part of the Department for Business and Trade in the UK government. Open Energy was launched through the Modernising Energy Data Access by Icebreaker 1, and Virtual Energy System Programme, well, that's what brings me here today. This summer, we completed the alpha phase of technical alignment, delivered through the Network Innovation Allowance of ESO, to consider the similarities in requirements of the Virtual Energy System data sharing infrastructure and the National Digital Twin Programme's integration architecture. We started with the use case exploration and high-level design, which have been developed in the exploration of those key factors, and evaluated this use case and high-level design with our technology and governance advisory groups. We developed a data sharing infrastructure technical specification based on a proposed use case, which focused on operational planning in electricity. And we were supported in the delivery of this by our research team comprised of Arup, Energy Systems Catapult, and Icebreaker 1. The requirements of the data sharing infrastructure specification were evaluated against the capabilities of the National Digital Twin Programme's integration architecture, and a gap analysis was performed to identify the priorities for development to demonstrate our use case. And we've then evaluated the development roadmaps of the Virtual Energy System Programme and the National Digital Twin Programme to understand where capabilities already exist or where they're already planned to be delivered in the near term. The results of this alignment were that there is a strong alignment between the requirements of each roadmap and that the integration architecture provides a starting point for the delivery of a pilot demonstration for the virtual energy system. We've also shared this research with Ofgem and the Department for Energy Security and Net Zero throughout this phase to help inform their activities across the digitalisation of energy. So our initial use case to explore the requirements of the data sharing infrastructure focuses on the exchange of topological information in operational planning timescales. This is a role governed by the grid code, and the electricity system operator's role is to coordinate between the distribution network operators and the transmission owners to deliver safe, secure, and economic operational plans to the control rooms. So if we take the system to the right-hand side, normally there's a wind farm connected from bulk supply point B through BSPA to grid supply point A up at the top of the diagram. The DNO plans to take an outage on this red circuit to perform maintenance. If no change was made, a fault on the purple circuit would lead to the disconnection of the wind farm. Therefore, the DNO would propose transforming bulk supply point A to be supplied by grid supply point B, where the risk is reduced. This has the effect of moving the wind farm output between grid supply points and can have an impact on transmission level operations, for example, restricting access to equipment in grid supply point B to avoid it increasing that risk to supply, or perhaps changing flows at the interface or on the transmission system itself. Currently, this planning process is performed by the sharing of Visio files, PDFs, and text descriptions to the electricity system operator, who then coordinate with the transmission owner to maximize security of supply and minimize those system constraints. Moving to a more model-driven process of coordination has the potential to reduce rework and potential for mistakes in transcription, to identify additional opportunities to reduce risk and costs on the system, to provide better situational awareness for neighbouring networks, and also to open up opportunities to consider future capabilities, for example, in automatic topology optimization. During the exploration of the interoperable technology stack, we developed a high-level design. This is shown on this diagram as a linear journey from left to right, which reflects the user journey for exchanging data. We start with an organization who has their data and models in their own proprietary structure and formats. The preparation node provides open source components, integrations, and development kits to align this proprietary data to an industry-agreed standard for exchange. Appropriate metadata is added, as well as security control labels. The data can then be made available for exchange to other organizations. Each organization is in control of how their data is labeled, who it can be shared with, and how it can be used. To enable other organizations to find and securely access this data, the data product is registered with its metadata into a data catalog in the data sharing mechanism. The data sharing mechanism will also include components to verify the identity of organizations and users. And over time, other features could be added, including services to support specific use cases or methods of data sharing. It also provides a mechanism for feedback on data products from the consumer back to the data provider. A trust framework provides the definition, implementation, and governance of the legal and identity frameworks and establishes the user's confidence and right and legal assurance where required to share data between parties. A data consumer can also deploy a data preparation node, and they can use the data sharing mechanism to discover and request access to data. The data does not travel through the data sharing mechanism once the connection is established and assured, the nodes can communicate directly. Preparation node is intended to be deployed across a broad range of technology stacks within each organization's control, expanding this across the sector. So the specification that we developed in the technical alignment phase has detailed this to a high-level design into an initial level 1 application architecture. This view shows the main components and the intended functionality of the data sharing infrastructure, but it doesn't prescribe specific technologies or design patterns, as that's down to the next step in the beta phase. The left side of this diagram defines the components of the data preparation node. This is the piece of software that energy actors can deploy on their own environment, whether that's on the cloud, on-premise, or hybrid, can be used to prepare data for sharing. You can see it includes a user interface to allow users to interact. It has data mapping services to standardize data into the required format or schema, for example, common information model. It contains data stores to house data through the standardization and exchange, integration components that allow organizations and their organizations to manage access to the data within their node and their organizational interface, and a metadata repository to capture metadata locally and then share it to the data sharing mechanism on the right-hand side. Schema assurance is provided to ensure that the data is validated and conforms to the required standard, and it can do this by checking against the schema repository in the data sharing mechanism. There are also elements in there for monitoring and managing components and for security services. And on the right-hand side describes the data sharing mechanism, which again includes that user interface, security services, a data catalog which will show all the data available from all the data users have access to through the data preparation nodes, and catalog to be able to search and find the data they want and request access. And the trust services provide the technical implementation of that trust framework, which will include things like digital certification and data licenses repository. So that diagram showed the components, and this diagram starts to show how this data exchange is performed using those components in practice. The data sharing mechanism acting as the control plane between the data preparation nodes. You can see the data sharing mechanism at the top, and a data preparation node from organization A on the left, and a data preparation node from organization B on the right. For the operational planning use case, as a simple example, we could consider the federation of SIM files representing the network asset data, and we imagine on the left-hand side we have a data distribution network operator as the data producer, and on the right-hand side we have the electricity system operator as the data consumer. Before they even start sharing, they'll need to register their nodes with the data sharing mechanism, where they'll be issued with a digital certificate to authorize and authenticate them. And as part of this, both organizations will have to agree to the data licenses and the data for the data products that are being exchanged, as well as the legal terms and conditions for using the data sharing infrastructure. This is delivered through the trust framework. The data consumer on the right-hand side uses the data sharing mechanism and its data catalog to search for data they want and find it, and then request access to it if they do not already have approved access. If required, the data sharing mechanism can then push the data request to the data producer on the left-hand side, and establish that secure channel between the producer and consumer, which is shown by the red arrows. When that's done, the data can be exchanged from the producer to the consumer in a federated way. The locality and ownership of the data always remains with the organizations and their deployed data preparation nodes. The data sharing mechanism is only there to enable that exchange of data to happen. The data sharing mechanism doesn't store or transfer the data, only the record of the metadata of the products available. The next step following this exploration of the technical requirements in the alpha phase is to build the first implementation of the data sharing infrastructure. So we've recently begun mobilization to build the pilot over the next 6 months, and this phase will provide a tangible end-to-end demonstration of the operational planning use case. It'll include the delivery of the initial requirements to deploy data preparation nodes, to register them with the data sharing mechanism, and to exchange those initial data products of the base network model and the topological information. This pilot development will enable us to define the system requirements to participate in the data sharing infrastructure, as well as the existing capabilities to prioritize from those existing capabilities, as well as to prioritize future development. It's also going to provide that early opportunity to gather feedback from users and from the wider sector to inform future development. Following the pilot, as described in the digital spine feasibility study outputs, we plan to develop a minimum viable product, which is expected to be in the area of strategic planning. And this will further iterate the capabilities of the data sharing infrastructure and begin to make it available for use for those early use cases. Extending this roadmap, we can give an initial indication on the future development and operational deployment of the data sharing infrastructure to the sector. This timeline aligns with publications from Ofgem in the sector-specific methodologies for RIIO-3, which indicates the adoption of data sharing infrastructure by the networks within RIIO-3, as well as their ongoing consultation on data sharing governance. The features of the data sharing infrastructure will evolve over time as more use cases are developed, leading to prioritization of future capabilities and future enhancements. This is represented by the cubes along the bottom, showing the increasing maturity of the individual components within the data sharing mechanism, or data sharing infrastructure, as those future use cases begin to be adopted towards 2028 and into the future. The plan is, through this roadmap, to test and iterate development and provide that early access within the next financial years to get that immediate feedback on the development before iterating that out across the sector and starting to onboard wider users across the sector towards 2030 and 2035. But to achieve digitalisation at scale and in these timescales, there's a need for sectoral governance of data sharing and collaboration in development of these common digital assets. As I said at the start of this session, this is both a social and technical challenge. Similar to the technical build of the pilot into MVP, the live operation and scaling of the physical data sharing infrastructure, there's a need for incremental, though transformational steps in digitalisation governance. Achieving this coordination can lower future system development costs by avoiding investment duplication and help accelerate decarbonisation by building confidence in digital capabilities. We began exploring the requirements for this governance through the creating a governance framework key factor and its report, and have been testing sectoral needs in our proposals with our advisory groups. Since then, we've evolved that through the Delivering Energy Sector Digitalisation report, which has been recently published on our programme website, and tests the existing and needed capabilities across the sector. The interim data sharing infrastructure coordinator would be responsible for the architecture, security requirements, delivery oversight and technology selection, as well as tender processes for delivering the data sharing infrastructure minimum viable product. And we believe we're well placed to deliver this role as interim DSI coordinator, aligned to our delivery of the minimum viable product for the data sharing infrastructure. There are a number of functions that are required to deliver an interim coordinator, which are described on this diagram, including a focus on architecture, on research and engagement, as well as forming a sectoral knowledge base of all the material related to the development and the implementation of the data sharing infrastructure. And in July, Ofgem published an 8-week consultation on the governance of the data sharing infrastructure, which runs until the 20th of September. This governance role is defined to operate between 2024 and 2028, with the objective of providing coordination and orchestration to the data sharing infrastructure so that it can be realized as a common digital asset for the sector. This is in line with RIA3 expectations set by Ofgem that all regulated networks will start to use the data sharing infrastructure for selected use cases, such as regulatory reporting, connections, flexibility, and strategic planning as RIA3 progresses. We believe that coordinator role needs to scale with the maturity and complexity of digitalisation in energy to take on a broader responsibility for strategic planning of those common digital assets that are required to design and operate the future system. As it grows, it will need to develop additional sources of oversight and advice, including a board and technical advisors. And it could take on the role of developing the strategic plan for common digital assets, taking in requirements from users across the sector. Additional research initiatives and challenge areas may be required to explore system challenges and propose solutions that work for a broader range of stakeholders. There'll also be more common digital assets over time, each of which will have their own delivery organizations and operators, which will require support and strategic guidance to ensure that when these are brought together, they reach the sector's goals. Through the Virtual Energy System Programme, we've been further refining these needs to understand the priority requirements and the steps that can be taken towards its development. And a lot of this thinking is available in that report that's been published on our website. So to conclude the overview of the Virtual Energy System Programme, we believe this coordination and governance is required to ensure that the capabilities of the data sharing infrastructure evolve to deliver the requirements of the increasing sensitivity and criticality of the use cases that become deployed through it. Aligned with this roadmap, we've identified 4 points driving these increases in maturity. The pilot stage, which we've started, is where the focus will be on establishing the secure by design of the platform. Minimum viable product stage, which is planned for the next year, or for next year, where the technology components will be configured in a small number of environments and start to be used by a range of users within the sector. Progressing beyond the minimum viable products is when we enter a private beta stage, when data services will be delivered against agreed service level agreements for a small range of early adopter use cases, and then entering a public beta stage where a whole range of use cases and new data services will be developed. But at each stage, as we pass through this model, we need to ensure that the security, maturity, the system capability is such that it can support those operational processes, both from the sensitivity of the data being exchanged and also from the criticality of the operational process that's being driven. So we'd like to just say thank you for the opportunity to share the development of the programme, and we'd welcome the opportunity to answer any questions you might have. We've also included on the screen here a email address. If you want to ask any detailed follow-up, please get in touch.
Brilliant. Thank you very much, Jonathan. That's really interesting. And sorry again for the technical issues we had earlier. We've already got quite a few questions in here, so I'll try and get through to them. Couple of quick ones from me, I guess. Could you share that report you mentioned, or one of your colleagues maybe share that in the chat? That'll be really useful. We'll also try and put that in the email to everybody. I have one question before I go to the chat about, I guess with the development of the DSI, the data sharing infrastructure, there'll be many other organizations who are maybe thinking or will be developing theirs. And because it might take a bit of time for the DSI to come to market, how is the thinking around sort of coordinating or integrating with potentially these projects which will be created now? Because I can imagine there might be some hesitation to develop your own sharing infrastructure while, maybe waiting for this one or not understanding what maybe some of the properties might be of it.
Yeah, so we've been engaging throughout this program as broadly as we've been able to across organizations in energy and digitalisation, as well as looking at cross-sector. So there are examples within rail and water where activities are ongoing to develop those data sharing infrastructures or proposed data sharing infrastructures. And we're working to collaborate with those to understand what their requirements are, how we can support each other. When it comes to other use cases, we're pulling in requirements, and we're developing that high level awareness of what future capabilities are required, the data products that might be needed to support them, and use that to drive our features as we develop through the pilot. I think it's important to recognize as we go through the sort of digitalisation transformation and the energy system transformation at the moment, that there is a need to move fast, and to be able to bring these together and integrate is going to require that engagement back and forth between programs. So I certainly would encourage programs that are working in this space to get in touch if we haven't already spoken to you, and we'll work directly to try and understand what we can do to help. And yeah, a lot of that engagement around ongoing activities in asset registration, flexibility, consumer consent, for example. Early thought is going into how those might integrate into a future data sharing infrastructure, and what that looks like as a longer term roadmap.
Brilliant, thank you. So I'm going to try and get through a lot of these questions here. There's quite a few come through now. So Fraser's asked, could you provide some contextualization examples for the early versus future use cases?
Yeah, so we started this program. We've got a series of those use cases we've been exploring through innovation, both with innovation led by ESO, but also projects that we're partnering on, led by other networks. Some of those at the moment are focused on flexibility. For example, our CrowdFlex project, where we're understanding the data products that they're exchanging through projects like Power and Wales Renewably and Pride, which is led by National Grid Group. Those projects are exploring different data products in the realms of flexibility, strategic planning. There's also been identified in the RIIO-3 sector-specific methodologies that requirement around regulatory reporting, and how providing it as accessed through systems controls might be better than Excel spreadsheets, for example. So we've got that broad range of high-level use cases. We have projects where we're trying to understand those data products. We're using those projects mostly to evaluate what those requirements might be, rather than to try and put them in a priority order of delivery at the moment. We're focusing on getting the pilot built, showing the capability, incrementally building that to the MVP, and then as the MVP matures, starting to onboard projects that are in a state of maturity to be able to join and participate.
Thank you, Jonathan. Simon asked for maybe some clarification about the tender process you mentioned there, because how does it work if the MVP is underway?
So the pilot project is underway at the moment. The MVP will follow in the next year. I think more to follow. I don't think I'll be able to give a concise answer on that. I think some of the perspectives around the requirements for tendering of common digital assets are included in that report on future digitalisation, but not on specific arrangements or agreements. Yeah, at the moment we're focused on pilot, MVP to follow.
Thanks. Robbie's asked a bit about how much of this information will be genuinely open and public. For those working on public policy, transparency and reproducibility are key. For example, PI PSA GB is fully open and relies on public data. Will this kind of open modeling necessarily remain outside the discussed ecosystem, and so need to continue to rely on OpenStreetMap, which is an ODBL1 license, or a Global Energy Monitoring, which is CC by 4 and the like?
Yeah, so it links in two elements here. So on the open data side, you'll see on the regulated networks, we've got the data best practice from Ofgem, which is a license requirement on networks, to consider presumed open, and states the licenses that can be used for sharing that data around CC BY and open government license. So that helps with the open data. And the energy networks are developing data portals on which requests can be submitted. For example, if you went to nationalgrideso.com, in the top right, there's the data portal, and on there's an email address where you can get in touch if there are specific products that you would like to see. So that's towards the open end. The data sharing infrastructure helps, in our view, to solve that middle grey area of not private, not open, shared data, where it needs that assured, controlled access, where it needs common principles around data licensing that make it really clear on where data can be reused, where it can be shared, where it can be developed and iterated further, and make sure that that's attached to the data. The expectation is that the data sharing infrastructure should be able to accommodate that broad range from open through to that more restricted end down to the sort of attribute and element level within data for security controls. That's the element that the National Digital Twin Programme's data preparation node, the integration architecture, has been developed on those security controls at a really fine-grained level to make sure that we can assign the right reuse requirements, the right access controls, approvals processes to reduce the friction of that shared data in the middle. Hopefully, as people become more familiar with those controls, it also helps to open up what's the open data. So as these products become integrated, it'll be possible to identify and streamline that process of opening up the data that can be open while protecting the data that shouldn't.
Thank you very much. Eric asks, how will the DSI program respond to the Clean Power 2030 requirement? Delivering decarbonised power in 2030 will require substantial data sharing for flexibility, for example. How can this program be accelerated, or is there an implication that the industry will do what is needed and then migrate?
Yep, so within Electricity System Operator and with our future role as National Energy System Operator, we're providing independent advice to government for the Clean Power 30 programme to both DISNES and to the Mission Control organisation. I think it's too early to draw conclusions on that, on the digitalisation. Obviously, digitalisation is required to drive the transformation of the energy system. But as for specifics, I think I would hold off providing any input on that at the moment, other than to say that digital transformation is critical for those activities around flexibility. But I wouldn't go into specific actions at this point.
Okay, thank you very much. Craig asks, is there a plan to export this technology once it reaches appropriate maturity? If so, do you envisage a scenario when we have a continental global DSI where all energy systems are connected?
Yes, we have been through recent months speaking with programs in Europe. They're looking at data sharing to understand what their existing capabilities are, what their proposals are. So there are examples across Europe. There are also examples globally in energy through the Global Power System Transformation (GPST) group, where they're looking at digitalisation actions and what can be done, in particular in an open source way, to allow collaboration on tools across energy sectors around the world. But also, I think it's important to realise that this transformation towards the use of data and digitalisation is also impacting other sectors like rail, like water, where there is value in understanding what's going on within the UK market and globally in those sectors as well. So we are working with those programs to make sure that we're reusing what we can, sharing what we've got, so that we can deliver this accelerator as quickly as we can.
Thank you. Maybe there's a clarification question here. David asks about, would it be possible to share existing data that's already collected by National Grid, TNO? Much of this data is already stored in one more data store, and so should be easy to enable. So I guess there's also a question here of like talking about the current data that's already shared and how the DSI plays into that.
Yep. So when it comes to data sharing at the moment, so the presumed open data best practice provides those mechanisms for triage for data request, meeting stakeholder needs, and acting on feedback. I would encourage looking at those data portals and making requests to the organisations that have the data if it isn't already available. I think we have over 100 different data products within our data portal that have been made openly available. One of the to draw a distinction there, one of the restrictions that exists within energy is this sharing your own data, to finding the data owner to be able to share it. It wouldn't be appropriate for the ESO to share all of the transmission owner's data or distribution network operator data. So there is going to be that necessity to work through the Energy Networks Association or through the regulatory frameworks to build up those common data products across organisations. So certainly we can help redirect to the right organisations if there are data products that people are looking for. But it is going to rely on a whole sector journey to build that maturity and make those products available.
Brilliant. Thank you very much. Eric's short question here, but who makes the design decisions?
So I think it's really important across this that the data preparation node in particular will be deployed by organisations across the sector. So it is important that we engage energy and bring bring in that range of stakeholders into those design decisions. At the moment, we're doing that through these projects, for example, through the pilot, working with that small range of users. But also we've had the advisory groups, and we're working through, at the moment, through the coordinator design process to be able to represent as many views as we can into those design decisions. The coordinator function provides that mechanism for escalating those decisions in a way, providing a framework around them, making sure that we're including the right people in them, providing that mechanism for people to have a voice. Making it open source allows organizations to contribute directly, potentially, to that design, and iterating features and building capabilities into it. All of it needs to be driven by that perspective of interoperability, of making sure that this is reusable across organizations. So it is critically important that we have that diverse set of views feeding into those decisions. But at a certain point, somebody does need to make that decision, which is where this governance framework that we're proposing comes in, that provides a route for that engagement through decision into implementation.
Thank you very much. Graham asked a question about use cases, and I guess the question here is really around how to encourage utilization as well here. So he asks, what use cases for data sharing do you have that, one, need a solution, and two, have industry support and enthusiasm to participate in data sharing? In their experience from NZTC is that there needs to be clear benefits in sharing the data, the willingness and interest is there, but the motivation and overcoming the hurdles need effort, i.e. what's the carrot? What can't we do that data sharing will enable?
So I think there's a long list of projects and themes that are attracting attention at the moment in energy around access to flexibility assets on the demand side, of deployment of decentralized assets at scale, coordination and facilitation of that, the optimization process around deciding on actions to take, both in a long term and a short term. So there are quite a broad range, especially in the innovation space, around strategic innovation fund challenge areas and the various networks innovation strategies, which show alignment on common challenges. I think getting them from that innovation space into production is where we then need the scaling power to be able to get more people involved. So there generally is that the networks and other users across the system have those challenges, and there are forums where they're being raised. Is how do we transform that into scaled action? I think it's the main piece again, which is where the coordination and governance function comes in.
Yeah, and I guess there was a follow-on to that really from Graham, which said, will the VES initiative drive a mandate, driven by, say, Ofgem? Is one solution you see as being viable?
So yeah, I think when we're looking at this from a use case perspective, you start to get down into the individual data products that are going to be needed to drive specific use cases, and those there will be some use cases that can only be unlocked by everybody in a sector delivering that piece of data or that data product. And in that case, we do need to understand existing levers through industry codes, contractual agreements between organizations, wider governance and policy, to make sure that we're pulling that in a common direction and not just creating copies of those data products with slightly different specifications. So we need to do this from a holistic end-to-end route in terms of how do you mandate that, where is the most effective position to do that. It is something that we're looking at as part of the MVP around what's the best governance implementation of this in terms of codes, licenses, regulation, legislation, that sort of full breadth of what are the options out there. And it's going to vary use case by use case, data product by data product.
Brilliant, thank you. I guess I have one quick question. Like potentially could be a huge amount of data flying around, and lots of sort of requirements for infrastructure, and also the maybe different latencies required, especially from my perspective of AI applications. Have you considered this, and what your thoughts in that area?
Yeah, so we're looking at it. It's about making those data products available in an efficient way, not duplicating those sources of data or those pipelines where we can avoid it. There may be some cases where, for resilience, you need alternate sources of information, for example. We're being led by use cases. So we use the phrase right time, not real time, when we're talking about the data sharing infrastructure. So those use cases, some of them will require low latency. For example, those sort of optimization decisions might require really quick action, really quick awareness of what's going on. There will be others where that's less critical requirement. So at the moment, that's the way we're prioritizing the features, and the strategic planning and the operational planning process. They don't have that sub-second latency requirement at the moment, but we are aware of further use cases down the pipeline that do have restrictions on latency and resilience. So we are designing this in a way that you can scale to achieve those future goals.
Thank you. Sorry, there's plenty of questions still here, and we've plenty of time here, so I hope you don't mind answering a few more. We've got Adam asking about, have you taken into consideration the work that's been done for NOIR, the National Underground Asset Register? The majority of organisations across the UK energy market are submitting data which is transformed into the MUDDI model, MUDDI, and seems to align well with the data sharing infrastructure.
Yeah, so we're aware of the NOIR program. We've had discussions with them in the past to learn lessons from their deployment and to understand where our requirements align and what we can do to collaborate. It's also an example of another program like that National Digital Twin Program engagement, where there's that important opportunity to make use of what others are doing. MUDDI providing that model for specifically geospatial data with underground capacity is another capability that could use the data sharing infrastructure to be able to surface that between organizations. And they've built a platform for the NOIR process at the moment to be able to do that. It's something that we've watched, we'll learn from and engage with. Yeah.
Thank you. Connor asks, will the platform provide a market hub to facilitate more granular and regional price signals to enable energy system flexibility? System flexibility. Excuse me.
So I think there's we need to not overpromise on what data sharing infrastructure can do. Data sharing infrastructure can provide the mechanism to be able to exchange that information, but it's going to be important to have layers of assets that exist to do this. Examples in the flexibility market, asset register consultation information that's going on at the moment from Ofgem in terms of flexibility data sharing, looks at how that information can be shared. But that, yeah, it's going to have to be, it's another example of those use cases that can be applied, that can be better integrated once you've got a data sharing infrastructure.
Thank you. Zhao Hong asks, how can community microgrid engage in the VES program? We are working on developing innovative net zero energy systems at building or community levels and would like to know how we could integrate the VES into our system.
Yes, it's an interesting challenge area. I would suggest the email address on screen would be interesting to understand more about the project. As we progress through that minimum viable product in over next 18 months period, that we'll be able to share more information on how this can be used in future, where making the components available, if we can, to those projects or to projects to understand their requirements, build on those capabilities.
Thank you. Ayrton asks, are there any big differences between the knowledge-based schema you would like to design for the virtual energy system versus the existing common information model?
Yeah, so common information model provides us with that ontology for defining electricity assets and the relationships between equipment. What we're referring to in the knowledge base is all of the design information, the process information around the data sharing infrastructure. More crudely, you could think of it as a wiki sort of style of a source of information that helps define the data sharing infrastructure, helps explain to people how to participate, common design themes, etc., to be able to adopt and collaborate and contribute to the development of that data sharing infrastructure. Inside that could sit the capability of common information model, and that may be an example of a piece of sectoral knowledge that can develop. There's examples like GBSIM profile defined by Ofgem, which is going to require collaboration across sector to help expand that ontology to reflect the wider energy system. So yeah, there are opportunities to contribute to the knowledge base of the sector.
Okay, thank you. Mez asks, can you provide more details on how the VES program has engaged with the European International Data Space Association artifacts, i.e. the widely used reference architecture for the prepare model node, sorry. Has a proper alignment exercise been conducted with the EU Common Energy Data Space work? Would this be quite efficient to lean on these existing learnings, especially for electromobility use cases with international scope?
So we're expecting to do more technical alignment with the European groups. We have had a series of deep dives into the technology and the solutions that we're both working on, and understanding where those relationships sit, where the reuse can apply. As that work develops, so yeah, we're working through it with them.
Thank you very much. This next question from Tim, I'm actually really interested in because there's obviously going to be some technical challenges with aligning everything together. Tim's specific question is, are there defined clock synchronization requirements for systems which require sub-millisecond data updates?
We're into fun topics where I get in trouble with our architects because I commit to things and then they come back to me. I don't have a detailed answer to that. I'll learn from previous presentations and not promise. But yeah, I'll take it away to our architecture team and see what they say.
Right. Thank you. Graham has asked about, well, I guess, does distributed ledger technology, like blockchain, I guess, play a part in the solution? If so, how? If not, why is it ruled out?
So we haven't defined it into any of the capabilities so far for pilot or MVP. We'll keep it in mind as we go through those features and those capabilities for MVP and beyond, and where capabilities exist, we'll do that research and try and achieve that system solution that can be deployed to deliver the capability.
Great, thank you. It might be our last question then. Simon asks, is there more detail on the outage planning pilot? They can't find too much information on the VES website.
We have a lot to publish at the moment. So we've just completed the project phase of the alpha research, where we have a lot of reports that we're looking to make public through the Smarter Networks portal from the Energy Networks Association. So over the next few weeks and months, we'll as we go through the release process of those documents, we'll be able to share more detail on the user journey, in particular around the personas that we've identified within the outage planning process, the data product definition, the exploration of common information model. We've also got reports on the interfaces with organizational systems in terms of where source data comes from for those products. So yeah, we'll look to publish those shortly. Probably best place to keep a watch on it is the Smarter Networks portal from Energy Networks Association, where we publish all the outcomes of all of our innovation projects. Searching virtual energy system, you can find all the previous phases up until that recently completed phase.
Brilliant. Thank you, Jonathan. I think that's all our questions. So it's been a very busy chat. So obviously everyone's very interested in this project. So I'll be really keen to see how this develops and where it goes. But I want to thank you very much, Jonathan, for giving us an overview and answering all those questions. We will be sharing the slides in the email for everyone who registered, and we'll also put the recording on the YouTube playlist we have for the Energy Systems Catapult. But yeah, thank you again, Jonathan. It's been really insightful and brilliant, and thanks to everyone in the audience who's asked such brilliant questions. Deep dived into the VES. Yeah, so thank you very much, and yeah, I'll put the link into the chat as well for that. So yeah, thank you everybody, and hopefully we'll see you next time when we'll have some other speaker. We'll be sharing some stuff on digitalisation. So thanks everyone.
Thank you very much.
Take care.
Cheers. Bye.